So for the gummy bear experiment, my gummy bear failed. My saltwater gummy bear did not shrink as much as it should have. It did, well, it like grew, but not as big as the tap water gummy bear. And I'm not 100% sure why it failed exactly. A little bit about the procedure. I soaked both gummy bears at the same time. But for this explanation, I first soaked the yellow gummy bear in tap water for about 10 hours. And I also soaked the green gummy bear in saturated salt water for about 10 hours. For the saltwater gummy bear, I put salt into the glass of water until it wouldn't dissolve anymore. And then I put the gummy bear into the water. When 10 hours was done, I took both gummy bears out and compared them to a gummy bear that was directly out of the package. So for a little bit of a comparison, the tap water gummy bear was the largest, and that is the far left yellow gummy bear on that picture right there. The saltwater gummy bear was smaller than the tap water gummy bear, but it was bigger than the original gummy bear, which should not have happened. The saltwater gummy bear is the green gummy bear in that picture. So as you can see, it's not as big as the tap water gummy bear, but it is still larger than the normal one, and it should have been smaller than the original gummy bear, which is the far right gummy bear. So a little bit about the tap water bear. It should have expanded, which it did. The water moves by diffusion through the bear's semi-permeable membrane, which this reaches an isotonic state where the concentration of water molecules inside and outside of the bear are the same. A little bit about the saltwater gummy bear. The gummy bear should have been the smallest of the three, but like I said before, it did not shrink like it should have. The gummy bear's gelatin construction will cause it to hold its shape and size even when the water leaves the actual gummy bear. The bear will shrink as osmosis causes water to leave the gummy bear. Just a little bit about the experiment. It had to do with osmosis. Just an example, if we imagine the gummy bear as a real living thing, it would be made up of tiny little cells, and each cell is surrounded by a membrane that protects the cell by keeping the cell parts inside of the cell and keeping other things outside of the cell. While it does stop most things, water can still pass through that membrane. We call the membrane selectively permeable because it decides what comes in and out of the cell. About osmosis, it's kind of like diffusion. When diffusion occurs, molecules move from a higher concentration of water towards a lower concentration of water. If the water outside of the cell has less water than the inside, water will move from the inside of the cell to the outside of the cell. This is what should have happened with the gummy bear that was in the salt water. The water had to move out of the gummy bear to even out the concentration of water, and the gummy bear should have become smaller with less water to fill it up. The reason the gummy bear in the salt water didn't get as big as the plain gummy bear is because the water didn't have to move as much to even out the concentration due to the salt in the water along with the gummy bear in the water too. The opposite happened to the gummy bear in the plain water. Water moved from the outside of the gummy bear to the inside to even out the concentration of water. As more and more cells gained water, the gummy bear became larger as the water filled up the gummy bear. So, relating the experiment to kind of a real life scenario, osmosis works in the same way for many cells as it did in this gummy bear experiment. When a person sweats a lot, the person is losing water at the same time. And so osmosis takes over and starts to pull water out of your cells, which is obviously not a good thing. So after water left the person's cells, the concentration of salt in the cells has increased, and this is why it's super important to drink lots of water.